we saw how we could change the threshold from 0 to 1 for deciding what's a positive value to navigate between the optimistic classifier and the pessimistic classifier. There's an actually really intuitive visualization that does this. It's called the precision recall curve. Precision recall curves are extremely useful to understanding how your classifier is performing. So in this case, you can imagine setting 2 points in that curve. What happens to the precision once your threshold is very close to 1? Well, the precision is going to be 1 because you're going to get everything right. There's very, very few things and you're very sure they're going to correct. But the recall is going to be 0 because you're going to say everything's bad, everything else is bad, so that's a pessimistic. On the other extreme of the precision recall curve, the point on the bottom there is a point where, the optimistic point, where you have very high recall because you're going to find all the positive data points, but very low precision because you're going to find all sorts of other stuff and say that's still good. And so that happens when t is very small, close to 0. Now if you keep varying t, you have a spectrum of trade-offs between precision and recall. So if you want a model that has a little bit more recall but still highly precise, maybe you set t equals 0.8. But if you really want really high recall, but trying to improve the precision a little bit, maybe you set t to 0.2. And you can navigate that spectrum and explore the trade-off between precision and recall. Now, there doesn't always have to be a trade-off. If you had a really perfect classifier, you might have a curve that looks like this. This is kind of the world's ideal, where you have perfect precision no matter what your recall level. This line basically never happens, but that's kind of the ideal. That's where you're trying to get to, is that kind of flat line at the top. So the more your algorithm is closer to the flat line at the top, the better it is. And so precision recall curves can be used to compare algorithms in addition to understanding one. So for example, let's say you have two classifiers, the classifier A and classifier B. And you see that for every single point, classifier B is higher than classifier A. In that case, we can always prefer classifier B. No matter what the threshold is, classifier B always gives you a better precision for the same recall, better precision for the same recall. So B is always better. However, life is not always this simple. If there's one thing you should learn about machine learning thus far, is that life in practice tends to be a bit messy. And so often what you'll observe is not classifier A and B like we saw, but it's classifier A and C like we're seeing over here, where there might be one or more cutoff points where classifier A does better in some regions of the precision recall curve, where classifier B does better in others. So for example, or C in this case. So for example, if you're interested in very high precision, but are okay with lower recall, then you should pick classifier C, because it does better in that region. It's higher up, closer to that flat line. But if you cared about getting higher recall, then you should choose classifier A, because in the high recall regime, when you pick T's that are smaller, then classifier A tends to do better. So you see its curve is higher over here. So that's a kind of complexity of dealing with machine learning in the real world. Now, if you just had to pick one classifier, the question is, how do you decide? How do you choose between A and C in this case? And you often need a single number to decide. As I was hinting at, depends on where you want to be in the precision trade-off curve. And there's many metrics out there that try to do single numbers, like something called FO measures, something called area under the curve. I'm less fond of those measures myself for a lot of applications than I am of one that's much simpler, which it's called precision at K. And let me talk about that, because it's a really simple measure, really extremely useful. So let's say that there's 5 slots on my website to show sentences. That's all I care about. I want to show 5 great sentences on my website. I don't have room for 10 million, for 5 million, just for 5. And I show 5 sentences there, 4 were great, and 1 sucked. I want all 5 to be great. So I want my precision for the 5 top sentences, for the top 5, to be as good as possible. In this case, our precision was 4 out of 5, 0.8. So I ended up putting a sentence in there that said, my wife tried the ramen and it was pretty forgettable. That's kind of a disappointing thing to put in. So for many applications, like recommender systems, for example, where you go to a web page and somebody's showing you some products you might want to buy, precision at K is a really good metric to be thinking about.